Hi everyone, this is going to be a video walkthrough on question 9 on CS61B Spring 2017 Midterm 1. So for this question, we will look at improving our deck interface by adding a new default method, okay? So our default method is going to be called remove. That will take in an item x and remove all items equal to x. Cool. This method should return true if anything was removed. It should remove false. It should return false if nothing was removed, and we may not use the new keyword. We can only write one statement per line, and we may not need all of the lines. Okay? If you need to determine that two items are equal, you use the dot equals method. In other words, we don't use equal equal to compare items. Exciting. So let's first recall what it means to have a default method in an interface. Okay? When we think about a default method, it means that anyone who implements this interface has access to this method, okay? And when we think about how to construct a default method, the best way of going about it is asking what functions do I have access to use, right? Well, we have access to these functions right here, because we know that anybody who claims to be a deck must implement these functions. As such, if anybody who claims to be a deck invokes the remove method, we can safely use any one of these functions because we know that they must have implemented them if they're supposedly a deck as they claim, right? So with that in mind, I think the best idea starting off is asking ourselves which of these functions that are provided for us can possibly assist in solving this question. And what's very important to note is that we cannot use the new keyword, okay? Because one possible way of doing it is that we can look through all of the objects, we can create a list containing all of the objects that are not equal, and then we can repopulate the existing array using that list. But we can't create a list. Correction, I should say array. Array is better in Java. We cannot create an array because that would invoke the new keyword. So another idea that I have is that suppose that we have a bunch of numbers. What we can do is we can kind of process them one by one, moving this order. We can ask each element, are you equal to x, right? If so, let's move you to the back. If not, let's delete you. Okay? So that's like the logic I'm going to be going for, and how we're going to implement that in terms of code is that we will iterate through our deck, right? A deck is just some sort of list, index by index, right? And what that's going to entail is that we will look at every object. Every time we get to an object, we will remove it from the front. And then we will ask ourselves, if it's not equal to x, let's add you to the back, right? And doing this strategy will ensure that if we execute the for loop n times, where n is the size, right? Then what we will successfully do is look at each of the elements in the list, right? And the order will also be preserved because we will suppose that, I don't know, x is 4 and we don't remove anybody, then we will first move 1 to the back, then we will move 2 to the back, then we will move this 1 to the back, and then 3. And we can see that this process indeed preserves the ordering, which is helpful because we shouldn't rearrange the ordering, right? All right. So all of this preface, let's dive in. So the first thing that we want to do, first thing that I want to do is figure out a way of determining what Boolean I can return, right? So there's a couple ways of achieving this. One really slick way is that we can keep track of the initial size. Then at the end after this process, we can just return whether the initial size is equal to the new size, right? Okay. So we can say int, actually I'll say length is equal to size, okay? The next thing that we want to do, or that I want to do, is iterate through each element of the given list, right? Make sure that we see everybody. To achieve that, we can go from I is less than length I++. Right? And what's important here is that since this length is not changing, we are ensured to execute this for loop at least length times, which means we will look at everybody in the linked list. So it's important to have length assigned beforehand. Otherwise, the size could change, and then it'll run into some complications in this condition here, okay? But with this in mind, the next thing that we want to do is remove the first element of the list, which is item, we'll say first, is equal to remove first. Okay, and then what we want to do is ask ourselves, is this item not equal to x? If so, let's add that item to the end. Okay, so how we're going to achieve that is we're going to say if not, well, first could be null, and we can't compare null objects using dot equals. So if first is not null and first dot equals x. Okay, what this is saying is that if it's not the case that first is equal to x, then what we can do is add last of first, right? And this is basically the logic. At the end, we need to finally return whether this current size is equal to the length. There's one other thing that the solution goes over, and that's this condition right here. It has this, and it has or, we go to that, x is equal to first. Okay, so what this second thing implies, it may be kind of confusing why the solution decided to add it, since it explicitly told us not to use dot equals or use double equals. So I think this actually confused me a bit. The way I reasoned why this makes sense is that supposing that x is null, right? We can't invoke dot equals if x is null. So it's possible that they pass in null, and we want to remove all nulls from the list, in which case this null equal is needed, because we can't compare null objects using dot equals, we have to use equal. So I'm guessing that it's for that small edge case right there that isn't clearly stated in the spec. But at the end of the day, I think if you guys miss that small check, that's totally okay. I think the logic for this question is more important. And yeah, that is all. I hope you guys enjoyed this video walkthrough, and I wish you guys the best of luck with your upcoming midterm. Yeah, have a good one.